we're going to take up the projections of solids. So here a square pyramid of 35 mm sides of base and 65 mm axis length rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. So here, since it is a square pyramid resting on HP, so obviously we have to start the problem from HP. So that is from the top view. So it is rests on one of its edges of the base. So the edge which is resting on HP has to be perpendicular to VP. This is the condition which we have seen even from the laminas also. So which is the edge which is perpendicular to VP? AD and BC are the two edges which are perpendicular to the vertical plane. That is the angle 90 degrees to the vertical plane. And these two edges are parallel to HP because the two endpoints are equidistant from the horizontal plane. In this case it is resting on HP, so obviously it is parallel to HP. So I am getting the true length here, that is BC and AD. And similarly, since it is a square of 35 mm sides, so we have written a square of 35 mm sides. Since it is a pyramid, so the pyramid will always have an apex point. So which is the apex point? The apex point is this O. So all the sides, all the edges or all the corners are joined to the apex point. So that means O to A, O to B, O to C and O to D are the edges which are called slant edges. Here slant edges. Similarly, the base edges are A to B, B to C, C to D and D to A are the base edges. And this shade is given only because it is a opaque surface and it is a complete solid. So we have a slant triangular face. OAB is one slant triangular face. OBC is the another triangular face. OCD is the another triangular face and ODA or the another triangular face. So there are four triangular faces in case of a square pyramid. When you look from the top view, ABCD is visible and O is also visible. So ABCD is visible and O is also visible. So we have joined between O to A, O to B, O to C and O to D. So we have joined between O to A, O to B, O to C and O to D. Similarly, this is the vertical plane and the horizontal plane looking from the front view and also looking from the top view. So here, how to draw this? So first we have to draw you measure 35 mm on the sketchbook and you mark this line AB. Then again you take 35 mm in this side, you mark that. So complete a square. Then draw the diagonals with a dark line. Draw the diagonal with a dark line. So we have A, B, C, D, O, O1. So now we have to write the front view. When you write the front view, when you look from the front view, I can see the height of the pyramid. The height of the pyramid is 65 mm. So from the XY line, you measure 65 mm and mark this point, apex point. When you project these points, you are going to get A is near to the observer and B is near to the observer. So A dash, B dash is visible and C and D is away from the observer. So C dash, D dash is in brackets. And when you look from the front view, O1 is hidden by the edge AB, so O1 dash is invisible. So O dash is a visible point, A dash is a visible point, you dark that. And O dash is a visible point, B dash is a visible point, so you dark that. Then A dash is a visible point, B dash is a visible point, so that you can dark that also. So this becomes the triangle. So this will going to be the first position, that is the axis, the square pyramid of 35 mm sides, a square pyramid of 35 mm sides of base. It's a base, so the base is here and 65 mm axis length. The height of the axis, height of the pyramid is 65 mm. So we mark that. Rests on HP, so it is resting on HP on one of its edges of the base. So here all the edges are resting on the base and such that the base edge is perpendicular to VP because one of the edges has to be resting on HP. So make that edge perpendicular to VP. Draw the project when the axis is inclined to HP. Now when the axis is inclined to HP at 45 degrees. So since the axis has to be inclined to HP at 45 degrees, so that means first we have to check whether the axis is in true length or not, because the inclination given is the true inclination. Since the axis given is the true inclination, so first we need to check the axis is in true length or not. Since the axis is parallel to VP, that is O1 is parallel to VP, so I am getting the true length here. Since this is in true length, so you rewrite the same sketch such that at an angle of 45 degrees. How to do that? First you consider any point on the XY line and mark that point A dash D dash, because that is AD is the edge which is perpendicular to VP. You can rest B dash C dash also on XY line. If you rotate it, if you are resting B dash C dash is on XY line, then you have to rotate to the right side. Since I am resting on AD which is on the left side, so I am rotating to the left side of the solid. Then here, since the axis is inclined to HP at 45 degrees, so the base is also has to be inclined at 45 degrees to HP. So here, draw by using the protractor, you draw a line which is inclined at 45 degrees to XY line. Measure the length from A dash to B dash. From A dash, you mark that point here using the compass and you name them it as B dash C dash. Measure the length from A dash to this point which is O1 dash and you mark that point A dash to O1 dash here. Since this axis is perpendicular to A dash B dash, so from here by using the protractor you measure an angle of 90 degree with respect to the inclined line A dash B dash and then draw that vertical perpendicular line to this inclined line A dash B dash. Then measure the length from O1 dash to O dash. From O1 dash you mark that point here to get that O dash. Then complete this triangle exactly the same as that of the first position. Then you write the top view. So how to write the top view? First you draw a vertical projector from O dash and then draw a horizontal projector from O to get this point O. Similarly, draw a vertical projector from A dash and D dash and draw a horizontal projector from A and D to get this point AD. Similarly, draw a vertical projector from O1 dash and draw a horizontal projector from O1 to get this point O1. Similarly, draw a vertical projector from B dash C dash and draw a horizontal projector from B and C to get these 2 points. Then we have to join all these things by means of thin lines, thin continuous line. So how to do that? First you draw a line between A to B, B to C, C to D and D to A, which is the connectivity. Then we have to join between O to A, O to B, O to C and O to D. All these lines has to be joined by means of a continuous thin lines. Then now we have to have the condition of visibility. So what is the condition of visibility? All the exterior edges of the boundaries of the solids are visible. So here OA is on the boundary, AB, BC, CD and OD, all these lines will be forms the boundary of the solid. So you draw that continuous dark line. So you draw a thick lines of this. So repeat, draw OA, AB, BC, CD and DO with a continuous lines, dark lines. Then when you look from the top view, O dash, B dash, C dash is a triangular face which is nearer to the observer. You can see here also when you look from the top view, OBC is the triangular face which is near to the observer, it is visible. So you dark between O to C and O to B. So this is a triangular face which is OBC. O dash, B dash, C dash is a triangular face. So that triangular face is here. OBC is a triangular face. Then the edge are now only the left out edge is AD. So we have one more condition. Two visible edges can never cross each other. So that means since OC is a visible edge and OB is the visible edge, So AD cannot be a visible edge because the condition says two visible edges cannot cross each other. So obviously this edge will going to become dotted line. So you have to make a dark hidden line. Okay. So here, in other words, if the edge or a corner is on XY line in the front view, is always invisible in the top view. So that condition also here it has been satisfied. Now the left out portion is whether O1 is visible or invisible. Since AB, BC, CD are visible but AD is invisible. Since AD is invisible, naturally since O1 is also becomes invisible, because if any one of the edges in this surface becomes invisible, then O1 will automatically becomes invisible. So it is evident from here also AD is the edge, because when you look from the top view, this triangular face is hiding this edge AD, and naturally O1 is also, it becomes invisible. So this portion is totally becomes invisible, and this is hidden by the triangular face OCD and also OAB. So naturally O1 becomes invisible.